Hello, everyone. Welcome to our series of webinars about serverless. And today we are going to talk about how to monitor at scale your serverless application on AWS. Whom we have today? We have Matheus. He is from AWS, Senior Partner Solution Architect. And me, Sergey. I'm from Intetics, working here as a project manager, and also I'm Cloud Solutions Center of Excellence leader. So all of you know a lot about AWS, and some of you who attended our previous webinars know about Intetics. But for those who attending us first time, let me say a few words about Intetics. So Intetics is a cloud-native consultancy that focuses on providing solutions to businesses, enabling them to exploit the potential of the cloud and its native features. Intetics integrated complex solutions with the cloud for different kinds of businesses for more than 10 years. And before we started, I would like to recap what we covered on our previous webinars. So originally we started from serverless. We discussed what is it. Like serverless, it's a cloud-native development model that allows us to build and run applications without managing servers. We discussed why serverless is so popular nowadays, what value it brings for us. For example, when we build a serverless application, we don't need to spend time on resource creation or maintenance. We also reviewed services that AWS offers us for serverless applications. On next webinar, we discuss how we can actually build and deploy our serverless applications. We reviewed common serverless architecture patterns, also discussed best practices for continuous deployment process, and also covered storage options for serverless applications, actually, where we can store our data when we build in serverless applications. And when we know how to build serverless application, how to deploy them, when we know benefits that serverless bring for us, it's a good time to talk about how we can monitor our applications, especially on production environment. And first of all, here, I want to speak about main challenge that our customers faced when they start working with serverless. First is monitoring. On our previous webinars, we discussed that serverless applications usually include a big number of components, services, configurations. And if you will take a look on this picture, you might think that it's a pretty complex task to monitor such applications. So today we will discuss what AWS offers us for this. Second is that for such big number of components, we need to automate all the processes. So we need to build continuous deployment process, and we need to know how to monitor it. So how to build a continuous deployment process, we already covered on previous webinars. So today we will discuss how we can monitor and control this process. And last but not least topic is cost efficiency. When customers start building traditional cloud solutions or who don't have any experience with the cloud, they usually think that serverless costs more than just to run resources on premise. And we already discussed that serverless applications, they usually cost less than traditional cloud, like EC2-based applications in a cloud, or running resources on premise. It happens because of different reasons. For example, when you use serverless, you don't need to, you just pay for resources that you use. So today we will discuss how we can explore and manage our costs for AWS resources. And now let's move on to our topic. And Matheus, I would like to ask you to tell us how we can monitor and scale our serverless applications on AWS.
Of course. Thank you very much, Sergey. Hello, everyone, and thank you very much for having me here in TEDx once again. I'm very excited to be here in this third webinar series that we are doing for serverless. My name is Matheus Arrais. I am a senior partner solution architect here on AWS. Been here for a couple years, and now I'm gonna present a little bit more how AWS can help with a native service for monitoring. And also, I want to make sure that, that Intetics can, address all the problems regarding monitoring for your application. So, okay, so you build the solution, right? You build the app. Uh, so it is a common, serverless application, API gateway, Lambda, and DynamoDB. So then what exactly could go wrong with this application? So many things actually. So you can have outage, you can have increase of latency, timeouts, errors. So you know serverless is not a silver bullet, right? So that is a couple of things that you need to take care of in the sense of to make sure that your application is up and running. So we have our CTO has a phrase that is very appropriate for this month. Everything fails all the time. So you need to make sure that your serverless application are up and running and you are capturing the right data in order to make sure that the health of the application, and also make sure that your customer has the best experience of the time, and your application is fast. You have availability, you have way to make sure that you address any possible issue. So let's take a step back real quick. So this is the traditional monitor layer. So in the traditional, there is a whole of numbers of layer in the stack that you can have, monitor yourself, from the network perspective, storage, physical layers, um, all the way up through, the many abstractions layer that we have into the visualization, into the business outcomes. So AWS spent a lot of time setting up, monitor, and alerting for these many components across the many years. So when you have um, serverless application, AWS manage for you these many layers. So when you have serverless, you are don't need to take care of of these many layers, as you can see in the screen. So we are gonna take care for the physical layer, virtualization, operation system for you, and you can focus and put more time into your business logic as part of the application code and the data. Um, so make sure that you're addressing properly your business needs. So monitor is more than watching, failures. So serverless application are resource that short living, right? So more devices, providing data, because your serverless application is actually using microservices strategy, most of them, and knowing your application is performing correctly is also monitoring more than just the failures, actually. So for instance, it is your applications actually performing as expected, even if your monitor dashboard is all green? Or another questions could be, are your customers getting the user experience that you want to give to them? Is there any usage of your application you're likely to know if more people are signing up or not, or how many pages people are getting? So those questions, it is important, and monitor if it is failing or not is just one of the steps that you could take. So that leads to the three pillars of the observability that we have. So observability consists in these three pillars: metrics, logs, and trace. And we're gonna take a little bit further, in the next slide. So metrics means getting number data about things that you want to track for your application. Thinking about request rate, or error rates, or any business metrics such as numbers of order places or payment receives. This is our metric. So logs is timestamps, record events that something happened. So a failure, or an error, or something information such as a state change or something like that. And trace are a single used or a transaction journey that you can see, end to end, the number of the application that requests or the user pass through. So for example, if I am alert uh, on a metric, I should be able to see and associate log and trace with a few clicks, and easily to navigate between the different components of my application. If I can do that, I can spend less time working out what exactly is wrong, and having more time to fixing the problem actually. So let's take a look about the observability goal then. So observability in these three pillars, failure is something just that needs to be embraced, so not just something that needs to monitor, like I mentioned. So we need to make sure that we are collecting enough data to actually understand the system. And if it is a data is missing, we can have some gaps in our visibility. So debugging is very important part of the observability. We're using data to collect that helps you to quickly troubleshooting as well. So actually doing testing in the production environment, not just in an isolated test environment, can help to make sure that your applications is up and running. So what exactly servers AWS has to tackle this? So we have two main servers about observability, and I'm gonna take a little bit deeper on those two in a moment. But we have CloudWatch, Amazon CloudWatch, and AWS Array. So CloudWatch, it is a service that collects monitor and operational data in format of logs, metrics, and also events, and also give you a nice, unique view across your AWS resource, application, and service. And you can set up, alerts for if something is important to you, and also you can visualize your logs and metrics side by side, and you can take automated actions based on those logs or those alerts and trace to help your troubleshooting issues. And AWS X-Ray is actually our tracing service. So it helps developers to analyze and debug, production application, and particularly helpful for those that build multiple, distribution components across, your applications, and you can see the journey for these different, components. So let's start with exactly the breadth and depth of CloudWatch and X-Ray. So as you can see in the screen, CloudWatch and X-Ray has numbers of features and can help with to collect and the logs and the metrics, passing through the monitor phase, that you can collect the data in using in a dashboard and alert that you can see what is going on and view the history, and also to see some trends as well. Moving to act, so you can act with alarm. So if alarm, for instance, fire, either based on a statistic value or even using anomaly detection, you can actually send an alert and run tasks automatically based on those events. And last but not least, you can analyze those logs. So running queries for visualization, or using analytics, to have more sense what is going on, and make sure that you are, covering in an analytics perspective too, and getting best insight as well. So AWS Lambda is a key part of any serverless application. So I want to make sure to emphasize that we AWS Lambda is also ready to integrate it with these partners here, ISV partners that also offers um, observability tools as well. For instance, Datadog and New Relic. So AWS X-Ray and CloudWatch are not the only options. We have this broad of partner ecosystem that you can use in order to integrate your Lambda, for instance, to have observability in those tools as well. So, okay, so let's start digging a little bit with metric and alarms first. So CloudWatch comes with a number of standard building metrics, right? These are automatically gathered by the Lambda, the API gateway, the DynamoDB that I showed in the beginning. Those are the metrics for API gateway and Lambda, default, right? As you can see, there is a lot of built-in metrics covering by numbers of invocations, performance, concurrence metrics, so on and so forth. And API gateway as well has 7 metrics that it is showing, like how many APIs that specifically call APIs having to, or how many cache details or error counts do you have, so on and so forth. You can have that up and running right now because, as I mentioned, is automatic built for you. Also, CloudWatch has a feature called CloudWatch Lambda Insights that you can go deeper in the insights about your Lambda. So provides you a clear and simple operational visibility of your functions by automatically collecting and summarizing the Lambda performance metrics, arrows, and logs that is already pre-built dashboard and saving you time, of doing this by yourself. So Lambda Insights is also a cool feature to have in your monitor dashboard because it's already automatic and can collect the performance of monitor across the board. Uh, you can take actions with CloudWatch as well. So CloudWatch, like I mentioned, has alarms, and based on those alarms that you can, put in a static value or even using automatic anomaly detections, you can actually have some actions. For instance, you can trigger an alarm based on the throttling on a Lambda, or using a data queue, or even an error rate, or even an API gate. You can make sure, for instance, that you have a successful rate of 99%. And if that number is not reached, then you can trigger an alarm, and that alarm could send, even a simple notification to your email or your messaging system, or even do something more automatically using another Lambda to trigger different other service, all those building blocks in order to do automatically, make sure that that alarm it is cover, and make sure that alarm is also gonna turn into green again. Okay, so that is the alarm piece and the metrics. But what about logging, right? So let's take a look on this log on the screen. So this log shows, of course, the timestamp. Like I mentioned, it's very important timestamp into logins, but also doesn't give me much information. I only can see that a request started, then an access was denied, and the request was finished. So you can use a structured log in order to have more deeper information about what is going on. So you can use and as you can see in the right side, is very easy to set up. It is because it's in a JSON format using key value pair, so you can it is very useful for troubleshooting. So putting the right information into your logs is a key part to make sure that your information requests, or that is specifically actions, it is logging appropriately in appropriate way. So, and you can easily visualize the log using a feature called CloudWatch Logs. So CloudWatch Logs has a lot of SDKs that you can use it in your lambdas. So coming from Python, Node.js, so you can easily in a single statement, you can just make sure that log is going to be send it to AWS Amazon CloudWatch Logs. So, and you can also create something that we call EMF, so embedded metrics format for custom metrics. So you can create your own metrics. So that's the importance to have this, because you can create your own business logic metrics and print those using the query or the statement in your code, and make sure that part of the code, it is logged and sent to Amazon CloudWatch. So very easy way to do it. As you can see on the right, this is an example of a better visualization or kind of a schema of the log that is more appropriated for this kind of example. So what are the things that you can do in a EMF? So you can publish, for instance, like I mentioned, business value. So revenue, signups, pages view, or even operation metrics like deployment feedbacks on call page, or even arrows. Any kind of metric that is important to your business and important to application health, you can do using EMF and publish that through Amazon CloudWatch. And you can analyze those logs, of course, using a feature called CloudWatch Logs Insight. So CloudWatch Insight, you can do a more complex query, because it's kind of a built-in platform that you can see on the dashboard of CloudWatch, and you can actually do queries and make sure in that specific request ID or something. So in this example for here on the screen, I'm creating a report which gets request ID and then also retrieve a sort of billable duration and display the first 100 results. So I can use that information to know if any Lambda function across one of more log groups that I have in my Amazon CloudWatch taking longer than I expected, and maybe investigate and maybe further do performance issues as well, or even improvements with my coding. Make sure that it is why it's taking so long, and do working backwards with my code and make sure why it's taking so long, and fix that. So you can have that information using log insights. Also, you can identify errors, right? And diagnose errors as well. So another way to use CloudWatch log insights is search for all log groups that you have in a single function or in a setup of the functions, and make sure what is the error samples or looks like. And that could help to troubleshoot, and also bring a pinpoint of the function's error without having to navigate by each individual function, and having a more holistic view across the board. So CloudWatch logs help you to save those queries as well. So if you have that problem many times, you can have that query saved and make sure that you run every time that you want to. Okay, Matheus, was a lot of information, but what about the last pillar, which is tracing, right? So we talk about alarms, we talk about metrics, we talk about logs. Let's talk about tracing right now. So tracing is another key point of observability. And with tracing, we actually need to talk about AWS Arrais. So AWS Arrais, like I mentioned, help developers to analyze and debug productions and distribute application, such as those built in using microserver architecture. So with Arrais, you can understand how your application is underlying servers are performing, to identify and troubleshoot the root cause of a performance issue or an error. So as you can see here on the right side, an image that you can make sure and you can trace individually, or even aggregate, to have a more, insights of the customer experience and usage of a specific, microservice. And some questions can raise up, like, for instance, what the root cause of the series of API faults? So which customers are being impacted, or how many APIs are involved? Is my downstream partner meeting my SLA? If you have so, or can I tune my critical code path in order to make sure that all that is movably? So as you can see here, we are showing an API gateway in that image that have 3 Lambda functions, and the top Lambda functions already returns with an error, showing actually a warning, because that Lambda function is actually fail. And the middle functions fail to find an item, but return successfully from the function. And then the API gateway differentiated between, the warning, the 400 level, and the 500 level error in the service map. As you can see, you can have a clear service map for this application that consists in API gateway and 3 Lambda functions. And you can make sure by analyze that using Arrais distributed for your many applications. So Arrais you can enable this in your Lambda because we have SDK that support many program languages such as Python, Node.js, Go, Java, so on and so forth. And as you can see, it's very easy also to capture that into your code, just a couple of statements, and then you're good to go. And make sure that you have appropriate permissions to do it. But it is gonna build that map for you in the Arrais map. Oh, okay. And also we have that we call Lambda Power Tools. So you can Google that. It's very easy, but you can also ask Intetics help with that because AWS Lambda Power Tools help you to log in, tracing, and metrics, custom metrics, custom applications using into your Lambda. And you also have available for Python, Java, TypeScript, and .NET. Okay, so last but not least, what is about the troubleshooting process? So I talk about many AWS service and features, but what exactly that helps me and how can I use that to actually leverage more observability, more intelligence to my applications, health, and so on. So Amazon CloudWatch alarms can help with the notification piece. So you set it up a value, and once the value it is switch or pass over, you're gonna receive a notification. That is very simple, but you can also make sure that notification have the appropriate stakeholders or even trigger an automated process. You can also have a feature I didn't mention in my presentation, but I want to mention here called Service Lens. So Service Lens also helps to you to map, identify points of failure, and also help you with further analysis into your application map. So also a very cool service that you can help in order to understand your serverless application. Then we talk about tracings. So check your traces, track your traces map, and where the request is going through, and the whole journey of that request is very important to have the holistic view about the whole API call, and you can help to have more analytics about with Arrais Analytics. Then it can help then to have a deeper analysis actually to your traces if you need it. And last but not least, logs. Logs is very important, like I mentioned, in order to make sure that your troubleshooting it is right, it is appropriate, and make sure what exactly happened in that specific timestamp. So you have log insights that you can look to your logs to a specific time frame, and then find the root cause of that specific problem, and make sure that you have appropriate tools set it up in order to just make any corrections into your environment. So in a nutshell, those are the servers that you can help AWS can help with or monitor your serverless application. And now I would like to pass to Sergey again to continue the presentation. Thank you very much.
Thank you, Matheus. Really a lot of very useful information for us. So now let's think what else we can monitor. On our first webinar, we reviewed reference architectures, and one of them was messaging serverless architecture. So Matheus completely described what and how we can monitor when we building API services, but for messaging architecture, for messaging applications, what else may be required from the monitoring perspective? So basically, sometimes our consumer, our Lambda, can process message from SNS. It may happen due to different reasons. For example, we may have incompatible versions of producer and consumer. Producer, it's who will publish message to SNS, and consumer, in our case, it's our Lambda. Or, for example, unexpected state change can lead to issue or even bug in our application code. So what we can do in this case? Here, our Lambda invokes indirectly, and we know that for asynchronous invocation, AWS Lambda automatically do 2 retries for us. It's good news because our application still tries to process a failed message, but what we can do if it still can't process it? So we already know that AWS will automatically collect most important metrics from managed services of AWS, but from the monitoring, we will only know that something is wrong with our application. Well, we can check logs, and hopefully we can find the reason why our Lambda can't process this message from the logs, and hopefully we can correct our application. But in this case, it means that new message will be processed, but previously failed message, we will lose them. So what we can do in this case? And here, DLQ can help us. DLQ, it's dead letter queue, and we can configure it on Lambda, and Lambda will automatically write a failed unprocessed message to DLQ with message information plus some contextual information, but will not include response from the Lambda. So in this case, DLQ is a very powerful debugging tool for us. And when we have debugged our Lambda application code, found the issue, corrected, and our Lambda is ready to process message again, DLQ allows us very easily redrive message by just clicking one button from the AWS console, and our message will be sent back to source queue, and our Lambda hopefully now will process it successfully. So in this case, we will not lose any data, we will not lose any messages, and we'll still be able to process them. So DLQ, its purpose is to handle lifecycle on unprocessed messages. And when we have DLQ, it allows us, for example, to add additional alarms on DLQ when new message appears there. So we will get notification about this. Or, for example, DLQ allows us to analyze failed message and debug our application against this message and information from this message. Or, for example, even if we give to our Lambda not enough time to process message from SNS, we can understand it and we can increase Lambda timeout and redrive all failed message from DLQ and not lose any from them. Now, let's move on to AWS CloudWatch Dashboard. So it's a customizable single view for metrics for our resources that may be spread around various AWS regions. With CloudWatch Dashboard, we can add the critical metrics for AWS services or some custom metrics for application from our application, and it gives us a single view of health status of our application. Also, using CloudWatch dashboards, we can put on the same dashboard, we can put resources even from different AWS accounts. Or, for example, we can add here some text information. For example, we can add here our playbook. Playbook, it's a guideline how to react on different operational events. So our team, from the dashboard, they can see what's wrong, what's worked properly, what doesn't work properly, and get this instruction what they need to do in what cases. So that makes CloudWatch Dashboard very powerful monitoring tool. We can use CloudWatch metrics, alarms, and logs information there, and it helps us to reduce time to investigate where we have issue, and have the issue at all, and focus on fixing it in case of outage or degradation events. Also, as its dashboard, it gives us information, and we can, based on it, we can detect anomalies or trends from our application. We reviewed today lots of services, tools, and approaches about monitoring. So now I want to do a short summary, and I want to do it in a form of quiz. I will ask the question, we'll give a couple of seconds, and then we'll show the answer, so you will have chance to think and answer yourself on the question. So the first main question is actually how we can understand that our application works correctly when we deploy it. And for this, we can use CloudWatch metrics and CloudWatch dashboard services. CloudWatch metrics will collect metrics from services or application, and using these metrics, we can add them to a dashboard and see how our application operates. Second important question that we want to ask is actually how we can get notification when something will be wrong with our application, when some errors will appear there. And for this, we can use CloudWatch alarm service. So we can use metrics from our resources and set alarms with some thresholds. And for example, when error rate is higher than we expected, or latency from our lambdas is higher than we expected, then we can send notification and react on this situation. And last question, actually, when we got notification, we know that something is wrong with our application. So how we can troubleshoot, how we can find the reason and correct it. And for this, we can use Arrais service or CloudWatch logs. Now, let's move on to the topic how we can monitor continuous integration and continuous deployment. On our previous webinar, we discussed how we can build continuous deployment process, what AWS services we can use, that we can build continuous deployment pipeline using AWS code pipeline service. And now let's discuss from the monitoring perspective, what we would like to know from our pipeline, from our release process. So we know that our code pipeline can do production releases automatically. To do this, we use automation tests. We strongly rely on them. And if automation tests passed for our current build, then we can release application to production. If our application can't pass automation tests, we are not releasing change to production. So as we do automatic releases, it's critical for us to know when deployment failed on pilot or especially on production environment. For example, when we deployed new version to production and automation test failed there, we should know about this to react and correct this situation for our application. What else may be interesting for us? For example, we would like to know when new version is deployed to production. For example, if some developer will merge change over weekend and they will be released to production, probably we want to know about this. Or, for example, we may want to do some change in Jira when new version is released. For example, we want to update labels in Jira or update versions there. So what we can do for all of these cases? For all of them, we can use code pipeline events. There are 4 of them: pipeline started, pipeline stopped, pipeline succeeded, and pipeline failed. We can subscribe to these events, and for example, in a simple case, we can send email notification, for example, when deployment to production succeeded, or we can send notification when deployment to pilot failed. Also, we can subscribe Lambda to these events, and we can implement any custom logic in our Lambda to do anything we would like. Code pipeline events, it's a very powerful tool to automate additional actions, additional operations around our release process. And now let's move to the last part of our today's webinar. And let's discuss how we can monitor usage and cost for our AWS resources. And first of all, let's review AWS services that we can use for this. First service is AWS Cost Explorer. This service helps us to visualize, understand, and manage our AWS cost and usage over time. It allows us to get high-level information. For example, we can get total cost for current months for particular AWS account. Or, for example, we can do a deep dive and filter our data, group them by some parameters, and use different granularity. For example, monthly, daily, or if we will enable it, even hourly. So, for example, we can check costs for particular AWS services that is used by particular application during last month, let's say. And of course, Cost Explorer can do forecasting for us. So it can show us, for example, how cost for our AWS resources will look like at the end of this month. All of this makes this tool very powerful from the Cost Explorer perspective and allow us to detect anomalies and trends of costs of our resources on AWS. Second service, it's AWS Budgets. So it's a powerful service that we can use to manage our costs and usage of AWS. Let's review two cases when we can use AWS Budgets. So, for example, we have a fixed budget for our infrastructure in AWS for months. So we can configure AWS budget with target cost amount and set notification, configure it to send notification for us when our actual budget will exceed our target budget. Also, AWS Budget service works with forecasted values, so we can configure to send notification even if forecasted value become higher than our defined budget. So, for example, if we are on the middle of current month and AWS Budget will see that at the end of the month we will our cost for AWS will be higher than we defined the budget, it will send notification for us and we can react on it. Second case relates for usage. For example, we can do similar thing with usage. We can set up AWS budgets to monitor for with some target usage amount for particular service, and it also can send notification for us when actual usage or forecasted usage is higher than we specified in a budget. When it can be useful for us. For example, we are using AWS free tier for some services, and we want to stay within it. So we can configure AWS budget, which will send us notifications that our forecasted, let's say, usage will be higher than free tier limits, and we can react on this. AWS budgets also it send events to SNS, and we can, as a result, we can just send simple notifications for someone to react, to manually review and react on this situation. Or, for example, we can subscribe our Lambda and automate some actions when such alert appear, which makes this tool very powerful for us. And now when we know services that we can use to explore and manage our AWS cost, let's discuss the best practices, what actually we need to do additionally to help us to make our cost management process to be simpler. So first is we actually need to define our organization metrics. What it means, for example, we need to understand from our organization perspective what we want to track. For example, costs for department, cost for particular team, cost for AWS services, cost for AWS accounts, and etc. So we need to define this. When we define this, we need to define our organization tagging policy. For example, if we want to know cost for resources that is used by a particular development team, in this case, we need to add team name in our tags, in our tagging policy. So later we can use this, for example, to filter or to group by teams and see costs for AWS resources between different teams, for example. Next step, as we defined our tagging policy, we need to actually implement them. We need to tag our resources. So all our resources on AWS will have meta information with all necessary properties. And last step here is that we need to configure our billing and cost management tools. As we discussed already, we need to enable Cost Explorer and set up AWS Budgets to control our costs. There is a link to article from AWS about best practices to monitor cost and usage information. So if you want to know more, please follow this link. And that's all for our today's topic. As we usually mention that serverless is a wide topic. That's why we split all the materials in a series of webinars. Today we had our third webinar about how to monitor our serverless applications. And on our next and last webinar from this series, we will cover security topic. If you want to know more, Intetics collected worldwide expertise in the cloud field, so feel free to check our white papers about cloud solutions. You can check our AWS expertise pack, check for case studies or solutions, or review clients' reviews on us on Clutch. And we welcome you to come us, and we are ready to make demo for you and develop offer based on your business needs. So feel free to contact us. And now I think we are good to move to question and answers section. So give me 1 second to check if we have any questions. So first question, Matheus, please help us with it.
Sure.
What does observability help me do?
Okay, yeah, helps with a lot of things. So I'm gonna mention 4. So helps with understanding the application health, right? So knowing what's going on and anywhere or everywhere into our system, and provide the best possible experience for your end users, which is key for any business. Secondly, accelerate collaborations as well. So when application issue occurs, engage the correct stakeholders for any alerts from the beginning. It is key. So the IT and the business team are able to automate repeatable tasks, and also make sure that they can use insights from the observability and the monitoring data, so they can take more user-centric approach in order to deliver better user experience. Third, can reduce costs, operational costs, because if you have across interest instances or Lambda functions, you can make sure to have improvements into your code and use less time of billing duration. And also, you can make sure to using reserve instance or concurrence reservate or even computing savings plan or savings plan, so they can help with cost. And for last but not least, I think, you know, users, right? So one of the leadership principle that we have here on AWS, it is customer obsession. So increase the customer satisfaction. Observability helps with that, right? So you can elevate your customer experience and business outcome when you are improving your application infrastructure, network, and availability, reducing, for instance, downtime, building a fast application or a more digital, seamless digital experience for your end users. So this allowed, you know, you and your internal teams and the end users to operate in a more an efficient way and to develop and then deploy a faster application. So I think that's the major ones.
Yeah, good answer. Uh, Let me check for more questions. Actually, I see a few more. Next question is, when do I use observability?
Yeah, I think, you know, it's pretty obvious, but I think you should use observability, every time that you can. Independently, if it is a small application or a large, of course, a large application, that doesn't need even to mention. But it is observability. It is key to understand those elements that we explore here in the presentation today, and also you have a lot of benefits, like the questions that I just answered. So observability should be able to tackle those problems, make sure that you proactive engage with your customer, or even trying to prevent any possible issues. So when you use observability, anytime that you want to build a solid and usable application for your end users, so and in order to increase your business, so any application at all.
Yeah, thank you, Matheus. And one more question, how can I investigate an issue?
Yeah, I think that last slide that I showed, the one that have a lot of kind of faces, help with that question, right? So you need to make sure that you are covered with AWS service appropriately, right? So AWS has these building blocks. You need to make sure that you are putting the right solution, the right service for the right purpose. So if you want to make sure that you are having traces for your application, so Arrais. If you want to make sure that you're having logging, enable CloudWatch logs, but also enable into your code in order to send that logs to the CloudWatch so you can action serve. So observability can help with troubleshooting when you use the right solution, something that we call purpose built. So the service, it is built for a purpose. So if you're using it in a correct way, and I want to emphasize here that Intetics can help with that, and Intetics has experience with that. So don't do it by yourself if you don't have experience. Use Intetics knowledge in order to do that, so they can create a stack of observability for that. So then you are can act proactive and reactive if anything occurs. So I think three major stuff: purpose build, solutionally, build your code to capture those information and send it to the service, and use a partner like Intetics in order to build that for you if you don't have experience, or even if you want to improve your observability stack, ask Intetics how to do that and how can they help with that too. So
Yeah, thank you. Let me check for other questions. Okay, I see one more, where I can find recording of previous webinars. And probably, maybe Matheus, let me answer on this question.
sure.
So we organize all our webinars on Brightal's platform. So you can search for Intetics and find previous webinars and recordings there. But I want to recommend you to find our channel on YouTube and subscribe on it. Here you can find all recordings from this series and also many other useful information for you. And I don't see other questions. So I think that's all for today. We will answer on other questions you will have after the webinar. So thank you, Matheus, for joining us.
Of course.
And thanks, Paul, also for joining. And see you on our next webinar.
Thank you very much.